Hello everyone, I am Aswani, Assistant Professor, Department of CSE AIML at MLR Institute of Technology. Welcome back another session of Artificial Intelligence. In this session, we are going to learn introduction of expert systems and phases in building expert systems. Let's see the overview of expert system today's session. Introduction to expert systems, characteristics of expert systems, advantages and disadvantages of expert system, phases in building expert systems. Let's see what is the definition of expert systems. So the expert systems are prominent research domains of AI. So it is introduced by the researchers at Stanford University in the Department of Computer Science. And let's look at the definition. The expert systems are the computer applications developed to solve complex problems in a particular domain at the level of extraordinary human intelligence and expertise. The expert systems are nothing but computer applications. So by using the expert's knowledge and human expertise, intelligence and human expertise knowledge, taking that, it will solve the specific domain problems. The complex problems will be solved using these expert systems. The definition is important. The expert systems are computer applications developed to solve complex problems in a particular domain at the level of extraordinary human intelligence and expertise. So, if any system says to that is an expert system, then that should possess some characteristics or properties. Those are expertise, symbolic reasoning, self-knowledge, learning capability, ability to provide training, predictive modeling, power. Let's see one by one. The first one, expertise. The system should provide or should exhibit expert performance, have high level of skills and possess adequate robustness. So by using this high level expertise and skill of an expert system, it will solve the problems and make it as a cost effective. So that expert system should be expertise in a particular domain. The second one is symbolic reasoning. The knowledge in an expert system is represented symbolically, which can be easily reformulated and reasoned. How it will be solved, why it will be chosen that method only. It should be in the symbolic. Then it is easy to understand by the end users. The third one is self-knowledge. So the system should be able to examine its own reasoning, why it is chosen that method only to solve the particular problem. It should have the capability to explain and examine its own reasoning to solve a particular problem by using some methods. The next one is learning capability. So the system, how the humans will learn by making some mistakes. Through the mistakes they will learn by observing, by experience, or by learning from the others. In the same way, here also a system should learn from its mistakes and mature as it grows. Flexibility provided by the expert system helps it grows incrementally. The next one is ability to provide training. So every expert system should be capable of providing training by explaining the reasoning process behind solving a particular problem using relevant knowledge. For example, if I ask you to solve a 2 plus 2 by a small kid like a nursery or a LKG student, then they will use the different methods. They will draw 2 lines, and 2 lines they will count all these lines. If I ask a 10th class student what is a 2 plus 2, then they will give answer as a 4. So the expert system should be able to give the explanation how it will be solved, how and why that one is chosen as a particular method to solve the problem. And it should have to provide the training also. Next one is predictive modeling power. So, for example, weather forecasting, what is going on, how much of wind speed, what is the humidity, all those things will be predicted. So here, this is one of the important feature of expert system. The system can act as an information processing model of problem solving. It can explain how new situations led to the change. For example, weather forecasting. What is the present weather, how it will be, what is the after 1 hour the weather is, the new situation led to the change, which help user to evaluate effect of new facts and understand their relationship to the solution. So these are the characteristics of an expert system: expertise, symbolic reasoning, self-knowledge, learning capability, ability to provide a training, predictive modeling, power. The next one is advantages of an expert system. So expert system are capable of advising, means investing something, then it will give some advices. Next, instructing and assisting human in decision making to take any decisions, then it will help to take a particular decision. Demonstrating, deriving a solution to a particular problem, diagnosing the disease, explaining how it will be solved, interpreting input, predicting result, justifying the conclusion, suggesting alternative options to a problem. Next, disadvantages. Expert systems are incapable of the following: substituting human decision makers. So it is not that much of capable of the substituting human decision makers, possessing human capabilities, producing accurate output for inadequate knowledge base. For example, if you give accurate information, then it will give the accurate output. If you give irrelevant or wrong input to the expert system, of course it will give the wrong output only. Refining their own knowledge itself it can't do. These are the disadvantages. The next one is phases in building expert systems. So in this building expert system, the first initial step is knowledge acquisition. This is the one of the major one. It needs to acquire the knowledge. The knowledge will play the vital role in the expert system to solve the major priority, the major area of expert system. What is the purpose of expert system is to solve the complex problems. Already we have seen the definitions. So to solve the particular domain problem, it requires the knowledge. Based upon that domain knowledge only, the expert system will solve the problem. To gain that knowledge, the first step is knowledge acquisition. Knowledge acquisition is the initial step in building an expert systems, involving extracting tacit knowledge from the domain experts. So there is a knowledge engineering process step will be there. It will take the knowledge from the experts and refine that knowledge, and taking the feedback from the experts, and it will iteratively explain and take the advices, and it will store that knowledge in the knowledge base. So this knowledge, often based on experience and heuristics, can be challenging to articulate. Knowledge engineers plays a crucial role in codifying this knowledge into the system's knowledge base. In the previous sessions, we have already seen knowledge representation. So there are approaches are there to represent the knowledge. By taking that knowledge only, the expert systems will solve the complex problems. So here, to codifying this knowledge into the system's knowledge base, this process is known as knowledge engineering. Knowledge engineer will play the vital role in this building an expert system. This phase, termed knowledge acquisition, is a research-intensive area employing various techniques to gather expert knowledge. So here, an initial prototype is developed based on expert interviews. By posing the queries, they will take the answers and they will prepare the initial prototype, and they will refine that prototype, which is then refined iteratively based on feedback. And scalability and modifiability are crucial for effective refinement without major code rewrites. So after preparing the initial prototype, they will take the feedback and iteratively they will refine that prototype, and they won't modify the major code as a rewrite. They will refine the somewhat comparing to the initial prototype. An expert system should be capable of explaining its reasoning and answering queries about the solution process. So this is the one of the major advantage of the expert system. The humans are anything, they are curious to know how it will be solved, why they have chosen only that method to solve that problem. So this expert system should be capable of explaining its reasoning and answering queries about a solution process with the updates involving localized knowledge additions or deletions. So a basic expert system comprises knowledge base and an inference engine. So it enhanced features like reasoning with uncertainty and explanation of reasoning paths booster expert system uncertainty capabilities. So here it will have the uncertainty and explanation of reasoning path booster as an expert system capabilities. So users often seek explanation for solution, believing them only if the rationale appears plausible. So if they know how the solution is derived, then only the people will believe on that solution. Next, let's see the phases building in the expert system. The first one is identification phase, conceptualization phase, formalization phase, implementation and testing phase. Let's see the first one, identification phase. So in this phase, the knowledge engineer determines important features of the problem with the help of human domain experts. So the parameters that are determined in this phase includes type of the problem, scope of the problem, the kind of resources required to solve the problem, and the goal and the objectives of the expert system. So the first one is identification phase. In this identification phase, the knowledge engineers determines important features such as type, scope of the problem, kind of resources, and goal and objectives of the expert system. The second phase is conceptualization phase. So here which will determines what are the concepts, relations and control mechanisms to describe the problem solving method. So in conceptualization phase, knowledge engineer and domain expert both are decide what are the concepts, what are the relations, control mechanisms to describe the problem solving method. Next, the third one is formalization phase. So in this phase, it will give the key concepts and relations in some framework supported by expert system building tools. So formalized knowledge consists of data structures, inference rules, control strategies, and languages required for implementation. So in formalization phase, in the conceptualization phase, it will derive what are the concepts, what are the relations, what are the mechanisms. In formalization phase, it will go through in detail what are the key concepts are required, like data structures, inference rules, control strategies, and languages to implement. The next phase is implementation phase. During this phase, formalized knowledge is converted into working computer program. So initially it is called as prototype of the whole system. So in the implementation phase, the formalization phase will be converted as a working computer program. This is initially called as a prototype. Next, last one is a testing phase. So iteratively it will evaluate. This phase involves evaluating the performance and utility of the prototype system and revising the system if required. After testing, if any changes are there, then it will be refined. The domain expert evaluates the prototype system and provides the feedback, which helps the knowledge engineer to revise it. After preparing the initial prototype, again it will be tested by the experts and they will give the feedback. By taking that feedback, the knowledge engineer will be revise that prototype. So there are 5 phases in building expert system. The first one is identification phase. What is the what kind of problem and what is the scope of the problem and what are the resources required, goal and objectives will be defined. And conceptualization phase, it will be identifies the concepts, relations, control statements to solve the problem. And next, in formalization phase, it will be derive key concepts such as data structures, inference rules, and languages are will be defined. In the implementation phase, the formalization will be converted into the working computer prototype. In the testing phase, after evaluated by the expert, they will give the feedback. By taking that feedback, knowledge engineer will be revise that, and it will be improvised. The next one is, what is knowledge engineering? This knowledge engineering is nothing but it will be referred as the whole process of building an expert system. So it typically involves a special form of interaction between expert system builder or the knowledge engineer, one or more domain experts and potential users. So this knowledge engineering consists of interaction between expert system builder, knowledge engineer, one or more domain experts and potential users. So in this, there are different ways and methods of knowledge engineering. The basic approaches are the remaining same. Here, the responsibilities of knowledge engineers requires the first one, ensuring the computer has all the knowledge needed to solve the problem. It contains all the knowledge to solve the problem. The second one is choosing one or more forms to represent the required knowledge. After taking all the knowledge, it should be represented in such a way to solve the problem easily. The third one is ensuring that the computer can use the knowledge efficiently by selecting some of the reasoning methods to solve the problem. These are the three steps, tasks, and responsibilities of knowledge engineer involved to solve the particular problem. This is the diagrammatic representation how knowledge engineer is involved to build the expert system. So knowledge engineer will pose the queries and domain expert will give the answers or solutions. Knowledge engineer will follow some strategies and domain rules to build the expert system. The next one is the role of the knowledge engineer begins once the problem domain for an expert system is identified. After that, the knowledge engineer will be involved and start building the expert system. They collaborate closely with the domain experts initially, gaining familiarity with the domain and users who are the potential end users and what are their requirement. Based upon that, they will familiar with that domain. This involves reading literature, conducting systematic interviews with experts to extract general rules and design an inference engine. So, to gain that knowledge, first there are multiple ways: literature, reading the literature, conducting the systematic interviews with the experts to extract the general rules and inferences, and design an inference engine. After conducting all this, after knowing the facts and rules of that domain, they will design an inference engine. The knowledge engineer translates the extracted knowledge into a computer usable format and ensure its correctness through expert validation. They also integrate mechanism for handling uncertain knowledge and determine the types of explanations useful and to the end users. So the human also can't guarantee that 100% of that statement is true. In such a way, here also it contains some uncertainty in this. So here the formal and experiential knowledge from experts is entered into the program gradually, addressing issues such as inference engine accuracy, appropriate knowledge representation. Through iterative testing and modification, the expert system gains competence. Means after refinement, multiple times refinement, the expert system gains the competence. Close collaboration with end users is essential throughout the development cycle. For each and every time testing, after that, it will be useful to reach the end users so that the suggestions or advices are taken from them, and again the knowledge engineer refine the expert system. Provisional decisions are made regarding knowledge representation and inference methods with the testing and small problems part to the validate design decisions. So here, initially unrealistic expectations about the benefits of an expert system. It's now understood that building expert systems for highly complex problems may not meet expectations. Means initially there is no such kind of expectations, but to solve highly complex problems may not meet expectations. There are two ways of building an expert system. They can be built from either scratch the data or using expert system shells or tools. So currently expert system shells are available and widely used. However, they are often used to solve fairly simple problems. Next, the knowledge representation. Already we have seen the knowledge representation in the previous sessions. Knowledge representation as a semantic nets, knowledge representation as extended semantic nets, and using frames also. So here also, expert systems relies heavily on knowledge as it's a primary ingredient. Based upon the knowledge only, it will solve the problems. The core strength of expert system lies in their robust repository of high quality domain specific knowledge, meticulously accumulated during the system development. This knowledge, distinct from other system information like user interaction or problem solving strategies, is organized using production rules, forming the knowledge base. These rules typically in the form of if-then rules. And here, expert system may employ unit-based representation encapsulating knowledge about entities and their properties. Units can denote entities or relation between them, fostering a more passive knowledge view. While these representations are common, AI researchers are constantly exploring new methods to enhance knowledge acquisition and representations. These current methods are often slow and laborious. The future of expert system hangs on developing more efficient approaches to build and manage vast knowledge infrastructures. So in this session, we have seen the definition of expert system, characteristics of expert system, next advantages and disadvantages, next phases in building expert system. Thank you.